Hi guys, and welcome back to my channel. So in the last month I had a couple of questions how I do the programming on my Attiny chips, like this one microcontroller, or the Attiny 85 or Attiny 13 and so on. So I thought it's maybe time to do a quick video on how I built my ISP programmer here, which I almost always use to program these Attinys via the ISP protocol. So first things first, I have to note that there are some other ways to program these tiny microcontrollers other than the ISP protocol, namely the UPDI programming, or you could use a so-called virtual USB connection to these chips. But hey, yeah, I stick with the ISP protocol because it never gave me problems and it works all the time. So for me it makes no sense to use another programmer. And if you are a beginner in programming microcontrollers, especially Arduino or these Attiny chips here, I can highly recommend to do it with the ISP programming method. So let's cut right to the chase, and I will show you the schematic how to hook things up. So here are the items which you need to build such a Arduino as ISP programmer. Obviously an Arduino. In this case I will use a Arduino Nano. Very important, it has to be a 5-volt version. Oh, you could also use, of course, an Arduino Uno. It will work just fine, but it's way too big for me, so I stick with the Nano. Also you need, of course, the header pins to solder it. You will also need some double pole female headers like this one. I used it in my build over here as the ISP connection to some other PCBs. You will need some IC sockets where you can plug in your Attinys. This one is for the Attiny 85. This one is for the Attiny 44. So some IC sockets. And you will also need a capacitor, electrolytic capacitor, 10 microfarad, at least 10 volt. You will need a couple of LEDs. These LEDs are not strictly necessary, but it is nice to have them on the board so that you can see what is going on. Of course, associated with the LEDs you need resistors, 220 ohms, a couple of resistors, and of course you need a kind of perf board to solder everything. Okay, so here is the wiring diagram, which is pretty straightforward. I have some LEDs here. Here is a green one to show me that the 5-volt supply voltage is present on the ISP header here. I have a LED which shows me that the programmer is programming something, so it should blink when it's doing something. I have a error LED on pin 8. I have a heartbeat LED on pin 9 This one is pulsing, and this one is showing me that the program on the Nano is working correctly. On pin 10 there is the reset of the target microcontroller. Pin 11 goes to the master out slave in of the target microcontroller. Pin 12 is MISO, master in slave out. Pin 13 is the serial clock signal to my ISP header here. So yeah, pretty straightforward. I have to mention that you need a 10 microfarad electrolytic capacitor here. This stops the Nano from resetting itself during the programming. So you have to program your Nano first and then add the 10 microfarad capacitor afterwards. That's the reason why I put the Nano onto a header socket. You could also make the 10 microfarad capacitor removable. Here is another important thing. Don't forget to make your female ISP connector here on your programmer board the exact mirror image of your target ISP connector. Otherwise your programmer will not work. So don't get confused. This drawing here is a mirror image of this one here. So I'm starting off with soldering my male headers here, DuPont headers, to my Arduino Nano. Okay, that's done. And for my programmer here, I will use double-sided circuit board, because I changed my mind a bit and I want to use SMD components to make it a smaller footprint. Okay, the Nano is in, the IC sockets are in, and the female ISP header is also in. It will work like so. Next comes the capacitor, the resistors, and the indicator LEDs. So here is the power LED with the 220 ohm resistor and the programming LED with the 220 ohm resistor. I have chosen the programming LED white and a bit bigger to give me a better indication. All the LEDs and resistors are in place, as well as the electrolytic capacitor here. And now I have to connect all my IC sockets here and the ISP header according to my cheat sheet over here. I will leave a link in the video description where you can download this cheat sheet. All the connections are done. Now I will cut the circuit board and it's time to test it. I connected my Arduino Nano here to my computer without the rest of the circuit board. And now let's go to the beloved Arduino IDE. So what I'm doing next is I go to Files, Examples, and look up for Arduino as ISP here, and I open this sketch. It opens in a new window. Okay, so this is an amazing piece of software, I have to admit. And what this software does, it makes your Arduino Uno or Nano, which is basically the same 328 chip, to become a ISP programmer. So in the description you can find all the details, all the pins which you have to connect, and so on and so forth. So what I'm doing now is I will upload the sketch to my Nano here. So I go to Tools, Board, where is Board here? Yeah, and I'm looking for the Arduino Nano. Here it is. Yeah, and I will upload the sketch to the Nano. Okay, the upload is done. Now we can disconnect our Nano here, and it is already flashed, and I can put the Nano back to my circuit board here. And that's it. The ISP programmer is ready to use. And here we can see the pulsating heartbeat LED. So the sketch on the Nano is working. Next step is to try it out. I will put a Attiny 85 into the socket here, and we will program a simple blink sketch onto it. So important to note that you need to put it in the right way around here. Like so. So let's test it with a simple blink sketch, and I open this basics blink, and because this sketch is written for a Arduino Uno or Nano, we have to change some things here because the Attiny 85 does not have a LED built in. So I changed that to, let's see, 3 and 4 would be okay. So here my pin 3 as an output, and I also, wait a minute, I also declare a pin 4 as an output. And in the blink loop here, I replace the LED built in for 3, and I add another to the right here for the pin number 4. Do the same here. Okay, turn the pin 3 low. and pin 4 high. Oops. To alternate between the two LEDs. Okay. Oh, yeah. Okay, let's compile it. Yep, it works. Now let's upload the code to the board. We go to Tools. I already chosen the right chip, which is an Attiny 85 and 8 MHz internal clock. Programmer, very important, you have to change the programmer to Arduino as ISP. This is what this makeshift programmer does. So we have to choose Arduino as ISP, and that's basically it. If you want to wait a minute. So if you want to upload your sketch to your Attiny, press Shift and upload. Yeah, that's it. The upload is done. You may have seen the blinking upload LED, and that's it. Your Attiny is flashed now and you can use it. Let's test it. Here is my circuit with the Attiny, 2 resistors, 220 ohm, 2 LEDs connected to the GPIOs 3 and 4, and yeah, that's working. I have added a local decoupling capacitor because my supply cable here from my 5-volt power supply is very long, and what I tend to do with all these Attinys, because I had issues in the past, I don't leave the reset pin floating. I always put a 10k resistor to VCC to 5 volt to pull the reset pin high in an external manner here, because as I said, I had some problems in the past which I discovered as a fault here with the floating reset pin. So if you have problems with your circuits, Attiny circuits, keep that in mind. Use an external pull-up resistor to pull the reset high. Here is another important thing. If you buy your Attinys, so they come right out of the batch here, there is no Arduino bootloader on the chip, so you have to burn the bootloader first before you put your sketch on. So you go to Tools and click burn bootloader, and that's pretty much it. So keep in mind, before you start programming your chip, burn your bootloader first. And what's left is to try the ISP connector, and let's program another AVR board here, an Arduino Nano, and again Arduino as ISP, that's important. Burn bootloader. Yes, it burned the bootloader, and now let's upload it to my target Nano here. I click Shift and upload. and the upload is done. And yes, my code works same like here on the Attiny. So here it is, my Arduino as ISP programmer. I could have built it smaller by sacrificing these IC sockets here, but sometimes they are very handy to have. Yeah, so if you liked this video, give me a thumbs up. If you think this video was somewhat interesting for you and you want to support me more actively, you can do this via patreon.com. I'll leave a link in the video description. Also, I'll leave links in the video description for the JSON files for the Attiny course, as well as the pinout for the Arduino Nano here, and how to hook it up to the ISP connector here. And so, because the video is way too long already for a simple thing like this, I say thanks for watching and see you next time.